Yesterday, we completely changed the way our users interact with the program. So now we allow the user to enter a to-do here on the fly. Add fix the bug. For example, you press that and it is added to the to-do items. Now, to be able to do that, we had to change from match case to if else. So now we check for expressions. So if add is in the user action string, user action is what we get from the user, so they enter add followed by the to do and so on. So we check if the part add is in that user input, and then we extract the to do from the user action, and we use list slicing for that. So we only get the characters that come after add, so 4 and everything after 4. And then we read the file to get the existing to-dos, we append the new to-do to the to-dos list, and we write the updated to-dos list. So then we have elif. So what happens is that if the user entered add, this block will be executed, and these other blocks will not be executed at all, which makes the code efficient. But if the user entered something else, the program will check if add is in user action. It will not execute this, but then it will check the next elif condition. So elif show, then it executes this. We didn't change anything from the show case. If the user enters edit, again we extract the part after edit using list slicing, and then we edit the existing to-do item as we did before. The same goes for complete, we use list slicing, we get everything after the 9th character, and so on. Otherwise, we have this else case here, which is the case when the user didn't enter any of these commands. They didn't enter add, they didn't enter show, not edit, not complete, not exit, but something else. In that case, we say, oh, your command is it's not valid. So that's what we did yesterday. Today we're going to improve the program even further and learn new Python features. So I'll talk to you in the next videos. There are currently 2 bugs in our program, an easy to fix one and another one which is more challenging. Let me explain you the first bug. So when the user enters a to-do such as add clean the bag, and they enter another one, add fix the drawer, and then show the to-dos, we get these to-dos next to each other. So how do you fix this? Well, there is no automated way. You should use your reason. You should know as a programmer where in the code you are currently. So we are adding to-dos. That means the bug is probably in the if condition, where we check for add. And this one is an easier one because we know that the problem here is the break lines. So we are not adding any break lines in here. Therefore, to do that, you need to go here and maybe plus \n, and that will add a break line. So just delete the existing to-do, save the file with Ctrl S, rerun, add clean the bag, add fix the drawer, show, and the bug is fixed. That was the first bug. The other bug, which is more challenging to fix, is this. Let's suppose the user wants to add the to-do item, add a new member. So they will write add and then add a new member. You press enter, you press show, and you get this successfully. So far, so good. But then, if the user wants to edit something, and perhaps instead of entering a number, they don't know how to use the program well, so what they do is they enter something like add a new member. So they aim to edit the add a new member to-do item, and they press enter. And what will happen actually is that if you press show now, a new item was added, add a new member. So add a new member was not edited. But what happened actually? Well, I'll explain you what happened. So when the user entered add a new member, what happens is that the program starts to check line by line. So it checks if add is in user action. And in this case, add is actually in the user action. Well, it's part of a to-do item. It was not meant to be sent as a command by the user. It was meant as a to-do item, but the program is not that smart. So the program was able to find an add string in the user action. Therefore, what it did is it added that to-do in the to-do list. So actually what it did is it got the characters after the fourth character. So basically 0, 1, 2, 3. And so then it got the space 4. So 4 is included and everything after 4. So that was added as a new to-do. So as you can see, we didn't get an error for this bug. So these kinds of bugs are not as easy to spot as the bugs which produce errors. Most likely you would find this bug after the users report an issue and then you fix the bug and you release the next version of the software with the bug fixed. So knowing where the problem is could be 90% of the work. So now that we know, it's easier to fix it. So how do we fix it? Well, again, we should use our reason. So it sounds like it's not a good idea to check for an add command anywhere in the string. So that checks if add is anywhere in the string. So the user action was something like add a new member and add in user action returns true. So if true, this will be executed. A better way I would think of implementing this is, instead of doing that, we do user action starts with add. Press that, you get false, because user action does not start with add. If you said user action starts with edit, then you get true. So starts with is a string method. So user action is pointing to a string, and starts with is a string method. You can check that using dir str. You will see that starts with is somewhere near the end. So here we go. So that method will check if a string starts with the input, the argument value provided to the method. Therefore, we go back to our program now and we say if user action starts with add, only in that case we extract the to-do from the user action. And we can do the same for the other conditions. So if user action dot starts with show, and I'll do the same for these other cases. Here we have edit, here we have complete, and here we have exit. So now our program is more explicit, it's more accurate. And let's have a run and check if everything is working well. So add by a camera, show, and if I press edit, add a new member now, we're going to get this error. So an error is better than wrong output. So the error in this case says that in line 26 we are trying to convert this object, which is a string, because after edit we had a string, but the program expects a number after edit, so the program has trouble converting that string to a number using the int function. So while it is better to get an error as opposed to having wrong output, it is still not ideal to just break the program like that for the user. So the user is going to get confused by this error. You want to make this more user-friendly, and we can do that using error handling. Now, error handling is a technique which helps you as a programmer control the error messages. And this is something we will do in the next videos. So instead of showing this error to the user, we will do something else. I'll teach you that in the next video. See you there. In the previous video, you saw that if the user enters edit and then instead of entering a number, they enter a to-do item, the program will end abruptly. And that is not a good user experience. So instead of showing this error to the user, instead of stopping the program, we want the program to continue. So what we want instead is, if the user enters this, we will tell the user that they entered the wrong command, and then we will let the user enter the command again by showing them this prompt. And that makes for a better user experience. So never break the programs like that for the user. So to not let the program end abruptly like this, we will use error handling. So what is error handling? Let me show you that to you. So here we are in the elif edit case. So if the command starts with edit, we get the number from the commands. The number is supposed to come after edit, but sometimes the user will enter something else. So what we want to do is we want to first try out. We want to try to execute these lines. So everything under the elif condition, we want to try to execute it. So what you do is you want to select these lines and then press tab. So you indent them. So now we have 8 spaces. And what you do next, you go here and you press enter, and then you say try and a colon. So as you can see, I'm introducing a new code block. Just like we had elif blocks, we had with blocks, we also had the case blocks. So everything under if, under with is indented. The same goes for try. So everything under try is indented. You see all these lines. All these are indented under try. So we try to execute these, and if there is an error, we go here in the same level with try. So try is in the same vertical line, as you can see, and you say except, followed by the error. The error in our case is value error. So you go back here and you say value with a capital V, error with a capital E, and a colon. So if there is an error, then we want to print out your command is not valid. And immediately after that, we want to give the user the opportunity to enter the command again. So we want to show this message again, and that message is produced by these two lines. So I'll copy them, go back here under the print function. I want to paste them in here, and I'll execute the code now. So type add, show edit, complete or exit. Let's say edit, add a new member. Press enter, and what we get this time is not an error. It is this message, your command is not valid, produced by that line, and then we have this prompt again. We can enter again the input. So if you enter again the wrong command, add a second member or anything like that, press enter, you get asked again for entering the input. Now let's try to enter edit 1. So when you enter edit 1, we get this printed out under try. You see print number printed out number 1, and here we enter the new to do, add a new player, show, and now as number 1 we have this add a new player. It's working, but it's not ideal. The ideal solution would be not to have repetitive code, because currently these two lines are the same as these two. That is not the best code optimization. So what we can do actually is we use the opposite of a break statement instead of using these. You remember the break statement breaks the loop, and the continue statement continues or run another cycle of the while loop. So what's going to happen now is this. Let's say the user enters edit, add a new member. The program will try to run these lines, and if there is an error, then these lines will be executed. Actually, if there is a value error, because there are different kinds of errors out there, it is important to specify the error here, because you don't want to get confused with all kinds of errors. So you want to execute these only when this error occurs. So when that error occurs, you print out the message in the command line, and then this statement here, what it will do is it will ignore everything that comes underneath here, and it will go back again to the beginning of the loop here in line 2. So it will execute this input function. Let's try it. Run the code, edit, add a new member. Your command is not valid. Type add show edit complete or exit. Edit add a new member. Again, we get your command is not valid. Type add show edit or complete or exit. Edit to. Enter a new to do. Update the OS. Press enter. Show and update the OS is number 2 now. So that was an example of the try except block. Before I close the video, I want to create another try except block here in this code, because we have another error here which might happen in the complete condition. Because if we run the code and the user tries to complete an item which is not in the list, for example item 23, when all we have is a few items, and in that case we will get an index error. It says that the list index is out of range. So that's the same error as if we had a list, for example A and B, so with 2 items, and you try to access item with index 23 or 24, so you'll get that error again, index error. So let's quickly handle this error as well, so that the user knows that he is out of the range of the items available in the list, in the to-do list. So again, we want to select all these, so all the lines which are under elif, and we want to indent them by pressing tab, and then we want to add try here. So we will try to execute all that code and then catch an index error. So that error there, index error. So if that's the case, we want to print out there is no item with that number, and then continue again. So which means that if the user entered a number which is out of range, we show that message and then we let the user enter a new command again. So continue will execute these lines again. So now if the user enters complete 23, they get this message and they get the chance to enter a command again. So that was the lecture about error handling. Let's keep going. You already know that when you try to do something that doesn't make sense, for example trying to add 12.3 to the string high, you get an error. So that is the error. But what you probably don't know yet is that there are 2 major types of errors in Python. You have syntax errors and then you have exceptions. So we have been referring to these as just errors, but in this code experiment video today, I will explain you the distinctions so that you can distinguish what syntax errors are and what exceptions are. So for that, we're going to be working on our app. And here is what I would like you to try for now. So please go under elif, where the complete condition is, so where we check if the user command starts with complete, and then we have this try block where we try to get the number after the complete command. So if the user enters complete 3, then we get the part after the index 9, which should give us the number, and then we have the file operation here, and then we remove the to-do with that number from the list, and we write the to-do in the list. Now, what happens if we remove this bracket here? So try to think what will happen we do have this try and except block, right? So that means the interpreter should try to execute this block. If it finds an error in that block of code, then it should execute these lines under except. That's how try and except works. But is that true? So are we going to get this printed out? So let's try. Run. And this is what we get. Syntax error, closing parenthesis does not match opening parenthesis. So why didn't the try except block handle the error? Why do we get a Python error here when we were expecting this to be executed? Well, the reason is that this here is a syntax error and the try except block only catches exceptions. What is the difference between a syntax error and an exception? Well, let's suppose that you are sending an email to someone and on your browser you have a grammar checker. So that checker is checking for grammar errors. Maybe you forgot a period or you typed in a word incorrectly. So that grammar checker will check for syntax errors. So when the grammar checker tells you that, oh, everything is okay, then you send out the email to a person. But then the fact that the syntax is correct doesn't mean your email content doesn't have issues. So the grammar checker is only able to check for syntax errors. But then the person on the other side, they can check for logical errors. So maybe you said that, oh, there's a file in the attachment, but you forgot to attach a file in that email. So that would be some sort of logical errors which the grammar checker cannot check. Similarly, with the Python interpreter, there are two instances of that interpreter program. So first, the interpreter checks your code for syntax errors. It doesn't go into the logic of the code itself. It doesn't check conditions, it doesn't check try except blocks, so it just looks at the syntax. Modern IDEs also have utilities integrated, which also are able to check for syntax errors. So all these underlines that you see are suggestions by the PyCharm IDE. And then when you run the codes, you get the actual source of the error, which in our case points to line 46, so that one in there, where we have a missing square bracket. So that is a syntax error. Now sometimes you'll also see that syntax errors are referred to by people as just errors and logical errors are referred to as exceptions. So a logical error, for example, would be something like if we try to remove an item using an index which does not exist in the list. So for example, if the list has 5 items, but we try to remove 8 here, so the item with index 8, then we would get an exception. So in other words, if I open the Python console in here, so if we have a list and we have A and B as items, then a.pop and you say remove item with index 5, that is not a syntax error, so this is an exception. Although you will see people, almost anyone, will just say, oh, we got an error. So they refer to errors in general, to syntax errors and exceptions as well. So from a practical point of view, the difference between syntax errors and exceptions doesn't matter as much as it matters from the theoretical point of view, so you should be aware that these differences exist. This way you have a better understanding of how your programs work. It is beneficial in certain cases, such as in here, when you use this try except block. Now you understand that a syntax error is not called from this block because of the way the interpreter works. So it has this grammar checker component which checks the syntax first, and then it has the actual interpreter which interprets what you were trying to say through the correct syntax. So once the syntax is correct, the grammar checker gives the green light, then the interpreter component, which understands the language, goes on and translates the instructions into machine language, and then your processor processes the information and it gives the output on your computer screen. And so that was the experiment I wanted to try for today, and I'll talk to you in the next videos. See ya. Hey, welcome to today's bonus example. In the code experiment video, you understood the difference between syntax errors and exceptions. Now there's another type of issue which neither the grammar checker of the interpreter nor the interpreter itself can capture. These are more logical issues which only humans can spot in a program, and for that you need to use different tools. So to discover what these issues are exactly, I will create a program which asks the user to enter the dimensions of a rectangle, and the program should output the area of the rectangle. So that would be something like width is equal to input you ask the user to enter the rectangle width, same for length, and you want to convert these into floats so that you capture a number instead of strings. So convert the entire input function, put it inside float, inside the parentheses of the float function. And then area would be equal to width times length. And you print out the area. So far so good. So you run the program, you enter 4 for width, 5 for length, and you get 20. But if the user enters 4 for width using a word instead of a number, then we would get this value error. So we want to tell the user, oh, you need to enter an actual number. So for that, of course, we use try and except, as you learned already. So what we do is we indent all these lines and we put them inside a try statement, and so we expect an error to happen in any of these, and that is a value error. If that happens, then we print out please enter a number. And note that we don't need the continue statement here because we are not inside a while loop. So that should be enough. Let's try again. 4, and we have this, please enter a number. So far so good. So we were able to successfully use try except to catch a potential error that the user might trigger. But what if we don't want the user to enter, for example, if we don't want the user to enter 5 for width and the same number for length? So the program will say 25. But what if we want the program to display a message to tell the user, oh wait, that is a square and we don't accept square calculations of areas in our program, so we want to show a message to the user. Of course, the try except block would not accept that, would not be able to handle such a delicate requirement, because that is not an error. Logically, for the interpreter, that is fine. The interpreter is simply multiplying two numbers, but this is an issue we should handle it in another way. Now that is where if, elif, else conditional blocks come in handy again. In this code we would write the if conditional after we get the width and the length. So we could check if width is equal to length, and if that's the case, we exit the program with a message. We say that looks like a square. You could also leave this empty and include a print function here and say here that looks like a square, but this is less code, so this exit function now will break the program, will interrupt it, and it will print out this string in the command line. So let's try it. 5, 5, and we get this. That looks like a square. The command line here in PyCharm is also able to highlight this in red because it's being printed out by that exit function. So if you don't want that color, then you should use print here and put that, as I told you, inside print. So what's going on here? Well, this is what happens. So we ask the user to enter some input. If there is an error, then this will be executed. So if there is a value error, actually, then this will be executed. If there is no error in here and in here as well, then here the if conditional will check those two values. So you see that an if conditional can be used, and it can be used without elif and else. Here it was not necessary to have elif or else. So an if conditional can be used when you want to check values, when you want to check conditions which do not produce errors. So they are programmatically correct, but the product is not acceptable from us. So the requirements, for example, here we don't want users for some reason to enter square dimensions, so we tell them, oh, we don't accept that looks like a square. So if conditionals do not catch errors, they check values. That's something I wanted you to keep in mind, and that's what I was trying to demonstrate with this example. So the difference between try, except and the if conditionals. Thanks for following this, and I'll talk to you later. In today's programming tool, I want to introduce you to an online-based IDE. You already know what IDEs are. For example, PyCharm, which is what we're using, is a program which we install on our computer and we can edit and run code on that IDE. But recently, there has been a trend of online-based IDEs which allow you to edit code and run it on a browser-based IDE. One of them is REPL, and in this lecture I want to introduce you to REPL, and I also want to show you the benefits and limitations of online IDEs, and of course recommend you whether to use an online IDE or a traditional IDE such as PyCharm. If you want the short answer, of course it is that you should use a traditional IDE such as PyCharm, but in specific cases, as you'll see in this video, it's good to know that online IDEs also exist because they have also some advantages in certain use cases. So replit.com is the website you should go to if you want to try out this IDE. So replit.com. Once you go there, you should create a free account, and once you have your account, then this is basically the dashboard, and here on the upper right corner you have a plus icon, or somewhere, it should be somewhere in here, so try to find it out. If you press that, you'll see this window, and it should ask you to specify what language do you want to work on, and that is Python, and then put a title for your REPL. So you are creating a REPL. What is a REPL? A REPL is a project. So just like we have projects in PyCharm where we put all our Python files, maybe text files, a REPL is also a project in this online IDE. So give a title to that project. My first project, for example. Now, the free plan is of course limited, so it doesn't allow you to set a project to private, so that's something important you should be aware of. Therefore, your project can be seen if others somehow stumble upon the URL of your project, they can see your code. So in your case, you can only choose public probably, and then press on create REPL. And that is your REPL. So that is a project. It looks similar to the PyCharm IDE interface in that you can see the file directory here. So main.py has been automatically created, and here is the editor area. You can write code in here, for example, print hello. I'll zoom in with Ctrl plus so you see a bigger font. And here on the right side, we have the Python console. And here on the right side, if we run the script, we should see the output. So press that green button there to run the code. You don't need to save the code, so that will run your code. And here you have the output. Now this area here can also serve as a Python console. So if you say print hi, so that is Python code, and you will get the output down here. Then this shell is a command line to interact with this server. So this is a server. It's located somewhere in the world and you are accessing it through your browser. The only way to access this server is by using this command line. So the computer does not have a graphical user interface as you have in your computer, where you can click and you can select files visually on your Windows Explorer. So this server is still a computer but does not have that sort of graphical interaction. For example, this is just an example. If you press ls and here in the shell and you press enter, then you should see the list of files in this current directory. The current directory is my first project. So you see main.py is part of this current folder, main.py, which is our file. So this computer is a Linux computer, it's not Windows, by the way. And that means Python is installed in this Linux computer. So the interpreter is installed, and when you press that button, this REPL service, they are executing your code using the installation of Python in this Linux computer. In our computer, when we use PyCharm, we are executing our code using the interpreter which we installed in our own computer. That is a very crucial difference you should be aware of. So when you execute programs, you use the interpreter of that Linux computer. And this is important because this brings us to the next point, which is limitations. So you cannot build certain programs in this REPL IDE because, for example, let's say you want to build a program which accesses the computer webcam and it does face recognition. You can build that program in your computer, you can run it with Python, and your computer camera, maybe you have a laptop, so the webcam will start and it will capture video. So that works when you are using your traditional IDE on your computer, but here this Linux server doesn't have a camera. So if you run a script which opens the computer camera, so if you have written such a program, then that program will not be able to run in this REPL IDE. Similarly, you cannot create graphical user interface programs. You know, programs where you have these buttons and text boxes, which is something you will create in this course, but you cannot do that using REPL, since, as I already mentioned, REPL just gives you access to this command line. It does not give you access to the actual graphical interface of the computer. Therefore, you cannot create desktop GUIs, desktop graphical user interfaces. However, some benefits of REPL. So why should you use it sometimes? Well, first benefit is that if you sometimes are on a mobile phone or a tablet device where you don't have traditional IDEs installed, then you can just go to your browser, go to repl.com, log into your account, and there you have all the REPLs. So you can access the REPLs by going to this button and then go to My REPLs. And you can scroll down, and down here, for example, we will see my first project. If you click that, that should open the project again, and you can view the code, you can start coding. So that's one benefit, you can program from a mobile device. Although that is hard to do, but sometimes maybe you are traveling or so it's handy to have your code in an online IDE. The other benefit is that you can share your projects with other people. All you have to do is click here on your browser address bar copy that URL and just give it to anyone, and they will be able to open their browser, paste that URL there, and they should see your project, and they can make a copy. They cannot edit your code, but they can make a copy of the project, and they can edit then their own project. And so that is a very easy to share your code base with other people. REPL does allow that. So that's what I wanted to introduce you to in today's video about programming tools. You know the benefits, you know the limitations, so feel free to use REPL when the need arises. But for this course, I highly recommend you to focus on PyCharm, because that's a real IDE which has all the features we need. So thank you, and I'll see you later.